Hello students, welcome to my YouTube channel Easy Mathematics. In this video, we are going to know about a very important topic which is required throughout our life. That is differential equation. So first of all, we are going to learn what is differential equations and what are the main aspects of it. After that, gradually we go for the core mathematics. So a differential equation is a relation between the dependent variable, independent variable and derivatives of the dependent variable. So just look, what is differential equation? Here three main terms are there. One is the dependent variable, another one is independent variable and the derivative of the dependent variable. So these equations looks like, here just look, it is 2x minus 3y plus 5xy is equals to 0. Here you will find out x, y, these are the two variables, and dy dx, that is the derivative of y with respect to x is involved. Here we can say that x is the independent variable, y is the dependent variable and dy dx the rate of change of this y variable with respect to x. So if in an equation all those terms are involved, then it is the differential equation. Here two more examples are given for the better understanding. D square y by dx square plus 4y is equals to 0. This is another example of the differential equation. And one more is dy dx is equals to y by x plus x into sine y by x. So at first elaborately we come to know about the dependent variable, independent variable, rate of change, and after that the main topics of the differential equation. Dy dx, this one is the rate of change of y. What is y? Y is the dependent variable here and x is the independent variable. Any derivative in the form dy by dx or whatever it be, the variable remain in the denominator is the independent variable and the numerator is the dependent variable. Now we come to know about the main aspect of your differential equation, that is the order of a differential equation and the degree of a differential equation. So how we measure the order and the degree of a differential equation? For that, in any differential equation, dy dx term should be involved. So that dy dx you should observe very minutely. If you will find out in an equation only this dy dx type of term is involved, then its order should be 1 because it is the first order derivative. If in the entire equation the highest order derivative is d square y by dx square, then the order of the differential equation is 2. If it is third order, then the order of the differential equation is 3. So in this way, by the highest order derivative involved in a differential equation, we can identify what should be the order of a differential equation. Likewise, when we are going to verify the degree of a differential equation, that time we should find out that the highest order derivative having how much power. If dy dx only involved in the differential equation, then its degree should be 1. Similarly, d square y by dx square involved but its power is 1, then its degree should be 1. And d cube y by dx cube, its degree is also 1. If it is dy by dx its whole square, then its degree 2. D square y by dx square its whole square, then its degree 2. Similarly, dy dx its whole cube means degree should be 3 in the given differential equation. So here is the definition for the order and the degree of a differential equation. First it is the order. Order is the highest differential coefficient occurring in the equation and degree is the highest power of highest order derivative occurring in the equation after it has been expressed as a polynomial of derivatives. So to understand the definition properly, we should come to know how to find the order and the degree of a differential equation. So how to find out this order and the degree? For that we should follow only two steps. First, write the equation as a polynomial of derivatives. Then no negative and fractional powers are allowed, so we should reduce the equation in such a manner so that any power of derivative should not be in the negative or in the fractional power. So with some example we verify and going to understand what is the order and the degree of a differential equation. So the first example is here for you. It is d square y by dx square plus 3 dy dx its whole square plus 4y is equals to 0. So here the highest order derivative involved is definitely this one, d square y by dx square. So now this one is the highest one and it is the second order derivative. That's so why we should say the order of the differential equation 2. Order of the differential equation is 2. And for the degree, as the highest power of this second order derivative is 1, so that the degree should be 1. Now the second example for you. Here it is the d cube y by dx cube minus 3 dy dx is whole to the power 6 plus 2y is equals to x square. Its order, when you are going to calculate, then its highest order derivative involved here is this one. It is the third order, so that the order of the derivative is 3. And regarding the degree, we should emphasize only on the highest order derivative. That means this one only. So its highest power is 1. So the degree should be 1 only. One more example for you. That is, if this one is your given equation, here look, 1 plus d square y by dx square whole to the power 3 by 2 is given. That one is equals to a into d square y by dx square. A is some constant. So here we should at first reduce this equation to the simplified form, because 3 by 2 is in a fraction and fraction power is not allowed to calculate the degree and the order. So that what to do? At first we squaring both sides of this equation, and after squaring we get 1 plus d square y by dx square whole cube is equals to a square d square y by dx square its whole square. Now the highest power, highest derivative involved here is d square y by dx square. So it is the highest, so it is the second order, so that the order of the differential equation is 2. And regarding the degree, if we simplify this entire term, then we understood that d square y by dx square its whole power 3 is the highest power which we can get after simplification, so that degree is definitely 3 here. Now one more example, that is d cube y by dx cube minus dy dx whole to the power 1 by 2. Emphasize on this power, it is not the general, that is the integer power, it is a fractional power, so you have to simplify. So its degree and the order you are supposed to calculate. Not only that, one more question is here for you, that is y is equals to 2 dy dx its whole square plus 4x whole into dx by dy. Here also you should emphasize on dx by dy. So these two equations are for your reference. You should do these two solutions by yourself. Find out the order and degree for the question number 4 and 5 and write its answer in the comment box. I am waiting for your answer. Okay, so just let me check also that how much you understand about the degree and the order of a differential equation. So all the very best for your answers. Next, it is the type of the differential equation. So now just observe. Differential equations, we come to know what it is. It involves the dependent variable, independent variable, and moreover the derivative of the dependent variable with respect to the independent variable. One thing, it is very clear that in an equation, dependent variable only be one. Only one dependent variable can be there, and one or more than one independent variables may be there. So depending upon this number of variables, we can have the different type of differential equations. So actually two types are there. One is the ordinary differential equation and another one is the partial differential equation. Ordinary differential equation, when you will find out when only one independent variable is there, and partial differential you shall find out when you have more than one independent variable. So remember, in a differential equation, dependent variable is always one, whereas the independent variable may be one or more than one. If it is one, then it is under the ordinary differential equation. If the independent variable are more in numbers, then it is under the partial differential equations. These differential equations again have two types. One is the linear differential equation, another one is the non-linear differential equation. Now, what is this linear and non-linear differential equation? So a differential equation is linear if the dependent variable and its derivatives appear to the first degree only. So when a equation is a linear, when the dependent variable and its derivative appear in the first order only. If not, then it is non-linear differential equation. For your reference, I shall give you the example over here. That is, when it is linear, then look, the example is dy dx plus x square y is equals to 1. dy dx is the first order, first degree, and y is the dependent variable which is also having the power 1. So this one is a linear one. For non-linear, just look here, x plus y its whole square dy dx. dy dx is in its first order, but y square we shall find out the second power. So it is non-linear. Similarly for the PDE, here the del z del x plus del z del y is equals to 1. This is the linear one, and this del z del x its whole square plus del z del y its whole square is equals to 4z. This one is the non-linear. So I hope you understand, when a equation is called linear, a differential equation is called linear and non-linear, it is clear to you. So these few basic aspects we come to know about the differential equation. This video is about how to form a differential equation if an equation is given. So for any given equation, if you want to form the differential equation, then we should look that which steps we should follow. So for an example, a general example at first I am starting with. So let a function is given which is a function of x and y, where one of these two variable is dependent and another one is the independent variable, and c1, c2 up to cn, these are the n constants are involved in this equation. So this one, if is equals to 0 is the equation, and in this equation for we are going to differential equation. So how to form the differential equation for this primitive? So to obtain this one, we should follow the three steps. So in the first step, what to do? We differentiate the given function with respect to the independent variable x. X, if we assume that it is the independent variable in the given primitive, then with respect to x, we should differentiate the given function first. Now differentiate the equation as many times as the number of arbitrary constants given in the equation. It is a very important step. I'm just telling you in the first step that you should differentiate the given function for one with respect to x. But how many times we should differentiate, that is decided by the number of arbitrary constants involved in that equation. So this is the second step. If in this given equation as n number of constants are involved, so we should take the derivative of this one n number of times. So first derivative for we get the one equation, second time when we do the derivative, then we get one more equation. In this way we shall find out n number of more equations. Now in the third step, we should eliminate the constant c1, c2, cn. That means this all n constant we should eliminate from all those equations to get the required differential equation. So the steps are very simple. Initially, whatever the equation is given, with that we should take the derivative with the independent variable, that is with respect to the independent variable. and this derivative we should continue up to the number of arbitrary constants involved over there, and in that process we shall generate some equations. In fact, the given equations, and if n number of variables are there, then n extra equations we generate. So total n plus 1 equations you shall find out. So using all those equations, we should eliminate the given arbitrary constants to form the differential equation. So with some example, we should verify that how to form a differential equation if a particular primitive or equation is given. So let us start with a very simple and known example. So a straight line, it is given. Everyone know what is the equation of a straight line? Let it is y is equals to mx plus c. So this equation is given and we are supposed to find out the differential equation for this function. Here m and c, m is the slope and c is a constant. These two things are given, and the given question n, you shall provided that m is arbitrary constant. When m is arbitrary constant, that time what should be its differential equation? If c is the arbitrary constant, then what should be its differential equation? And when m and c both are arbitrary constant, then what should be its differential equation? So let us do one by one. At first, this one is your given equation, and when m is the only arbitrary constant, that time what should be the differential equation? So what to do? Only one arbitrary constant is there, so that we should do only one time derivative with respect to x. So after doing the derivative, we shall find out dy by dx is equals to m. Now this is the arbitrary constant which we should eliminate in between 1 and 2, and if we eliminate these two, we should substitute instead of m this dy dx, and after substitution we shall find out this one. So which is our required differential equation? It is so very simple. Now the second case, that means when c is the arbitrary constant. If c is the arbitrary constant, then what to do? We just simply again take the derivative with respect to x, and after derivative we shall find out dy by dx is equals to m. Just look, it is independent of c, that means c is already eliminated over here, so that we can say this is dy by dx is equals to m itself is the required differential equation. So now it is the third case. In the third case, in y is equals to mx plus c, m and c both are the arbitrary constant. As two arbitrary constants are there, that's so why we have to differentiate twice. So first time derivative we know it is dy by dx is equals to m, and when we do the second order derivative, then it is d square y by dx square is equals to 0. So look, in this equation we will have it is independent of m and c both, so that we can say this one is the differential equation. Here not required to eliminate c and m because it is already eliminated from here. So this is your required differential equation. Let us do one more example. So in this example, the given equation is y is equals to ax plus b, where a and b both are the arbitrary constants. So what should be the differential equation of this one? So for this, as there are two arbitrary constants, so we should take the 2 times derivative. So now first time derivative when we will do, then we shall find out dy by dx is equals to minus of a by x square. So now we should take the second order derivative. So for the second order derivative, we just do slight adjustment. This adjustment is x square we multiply here, so that the equation becomes x square into dy dx is equals to minus of a. Now if we differentiate, then it is the uv type function, that means two functions are there. So first function derivative of second plus second function derivative of first. In this way if we do, then we shall find out this one, and here no arbitrary constants are involved. So this is our required differential equation. Let us do one more example. So find the order and degree of the differential equation of the family of curves. This one. So this one is a given curve. For that, at first we should find out the differential equation. After getting the differential equation, we should say what should be the order and degree of that differential equation. So at first we should find out the differential equation. So for that, at first we should check how many arbitrary constants are there. So only one arbitrary constant is given. So we should take the first order derivative and only one time with respect to x. So if we do that, Then the derivative we shall find out y into dy dx is equals to c. Now this we should eliminate c from the given equation and the first order derivative equation. So after this elimination we shall find out y square is equals to 2y dy dx into x plus root over of y into dy dx. We just simply substitute instead of c the y dy dx in the equation number 1. So after this substitution and simplification we shall find out, just look at this simplification here. So after the simplification we shall find out the differential equation as 4y into dy dx its whole cube minus 4x square dy dx its whole square plus 4xy into dy dx minus y square is equals to 0. So now can you tell me what should be the order and the degree for this differential equation? I hope you can, because in our previous video we come to know how to find out the order and the degree of a differential equation. So I am not going to do the answer for you, and I am expecting the answer from you peoples only. So that I am waiting for your reply. Just write your answer for this question in the comment box, and if you are giving the wrong answer, I shall give you the explanation again. But I recommend to go for the previous video if you have any kind of doubt to calculate the order and the degree of a differential equation. This one is a very important video regarding the solution of differential equation. Here we come to know about the different type of solutions for the differential equations. Basically, 3 type of solutions we should calculate for a differential equation, and these solutions are as follows. So the solution for the general solution and the singular solution, these are the basic 2 solutions. Now one more type of solution is the particular solutions, which we can generate from the general solutions. So what is the solution and how we shall find out this general solution or particular solution or singular solution for a differential equation? So before that we should come to know what are those equations. So what are those solutions basically? So first of all, a solution of a differential equation is a relation between the dependent and independent variables not involving the derivatives. So what is the solution? I hope you just go through my second video of the differential equation. There you are supposed to construct the differential equation by using a given equation. So in the first example you have there y is equals to mx plus c, and corresponding to that you are supposed to calculate the differential equation. So that differential equation for the solution is y is equals to mx plus c. I hope you understand. From the solution actually we have already constructed the differential equation. Now from the differential equation to solution we are going to construct. But these solutions are which type and how these solutions are look like, we are going to know in this video lecture. So at first with an example we should do that. So let d square y by dx square is equals to 6x. This one is your given differential equation. Its solution is y is equals to x cube plus c1x plus c2. How we shall find out this one? For that we have the upcoming videos, but just right now you just think of that this differential equation for this is the solution. Here y is the dependent variable, x is the independent variable, and c1 and c2 are 2 arbitrary constants. Here you should note that as the given differential equation is of second order, that's why 2 arbitrary constants are here. It is always been happen that the order of the differential equation define that how many arbitrary constants should be there in the given equation. So now if this one is the solution for the given differential equation, then this is called the general solution of the given differential equation, which is also called the complete primitive. So general solution is very simple. Now any solution that can be obtained from the general solution by giving particular values to the arbitrary constant is called a particular solution. So what is particular solution? In this general solution, if we put some arbitrary values to this arbitrary constants, then what the answer we shall find out, that is our particular solution. That means for the particular value of C1, C2, we shall generate a particular solution. So if we suppose substitute C1 for 0 and C2 for 1 in the given equation, then we generate y is equals to x cube plus 1, which is called the particular solution for the particular value of C1 is 0 and C2 is 1. Now it is the next one. This is the singular solution, which is a very important one. So what is singular solution? So the solution of a differential equation that neither be obtained from a general solution nor by the usual method of solving the differential equation is the singular solution. So how it looks like? It is a very hodgepodge now. It is neither coming from the general solution and nor coming by the usual method of solving a differential equation. So how it looks like? So for more elaborately, just let me tell you what is the singular solution. So a general solution consists of family of curves. Whenever you find out the derivative, that means differential equation, its solution is coming that it involving the arbitrary constant. So for different arbitrary value, that means different values for the arbitrary constants, you shall find out the different curves. So that is basically the family of curves generates in the general solution of a differential equation. So a general solution consists of family of curves. The envelope of that family of curves is the singular solution. I hope you know the envelope. Envelope you shall find out when you come to know about the evaluates, invaluates in your previous semester. There you shall find out what is the envelope. So still I am telling you that an envelope is defined as the curve that is tangent to the given family of curves. What is envelope? An envelope is defined as the curve that is tangent to a given family of curves. So how to get the envelope for a given family of curves, that I hope already you know. So from there you can easily calculate that envelope is your nothing but the singular solution. Not only that, in other words, we can define a singular solution as an ordinary differential equation for it is a solution that is one for which the initial value problem, that is the Cauchy problem, fails to have a unique solution at some point on the solution. I hope this is out of your head. So not required to go through this definition right now. I am just giving you the definition. If anyone interested regarding the topic in depth, then you should go for this definition. So what is the definition? A singular solution of an ordinary differential equation is a solution that is one for which the initial value problem, that is Cauchy problem, fails to have a unique solution at some point on the solution. So with an example, let us consider the singular solution. So first of all, the given example is dy dx its whole square is equals to 4y. So this one has a general solution y is equals to x plus c its whole square. How this general solution will come, that I shall give you in my upcoming videos. Now right now you just think of that the general solution for this given differential equation is this one. So this one is the family of parabolas. For different c's we shall find out the different parabolas, because this is the equation of a parabola. So this is the family of parabolas. This is the general solution also. Now the line y is equals to 0 is also a solution of the given differential equation, but it is not a member of the family consisting the general solution. Y is equals to 0 we shall never find out from here, but it is the solution for this differential equation, and this one is called the singular solution. But how we shall find out this one? Being an envelope, singular solution can be found from the general solution by solving the maximum or minimum value problem of finding the value of the parameter c for which y has a maximum or minimum value for a fixed x. So how to find out the singular solution? By using this method, maximum minimum value problem. So this one is our given general solution. From there we should find out the maximum or minimum value of y with respect to c. So that at first, how to do that? We just take the derivative of y with respect to c. So that we shall find out dy by dx is equals to 2 into x plus c. If we equate it to 0, it will give us the value c is equals to minus of x. Now we should verify that for this particular value we are going to find out the value of y as maximum or minimum. Very simple, we take the second order derivative. If it is less than 0 then maximum, if it is greater than 0 then it is minimum. So we shall find out here it is the maximum value giving for y. So now if we substitute this c value minus x here, then it will gives us the value y is equals to 0. That is this one, which is our singular solution. So in this way we can find out our singular solution. So in this video we come to know about three different type of solutions of a differential equation, that is the general solution, particular solution and the singular solution. Singular solution is so very important for the for your future studies. Our target is to find out the solution of the ordinary differential equation. But this ordinary differential equation for any solution exists or not, and if the solution exists, then the solution is unique or not, that sense is required more. So that before knowing how to solve a differential equation, we should come to know the existence and uniqueness criterion of the solution of the differential equation. So at first I am giving you the structure of a differential equation. So here it is, dy by dx is equals to f of xy. This is the function of xy. dy dx is equals to function of xy. This is the general form of a first order first degree differential equation. This equation we can also write as m dx plus n dy is equals to 0. This is just the another form of this one. We can derive this one from this form only. We just multiply dy dx from dy and dx we should multiply this side and we can rewrite in this format. So here m and n are either the function of x and y or it may be a constant. So this is the differential equation. Now for this type of differential equations, the solution exists or not, and if it is exist, then it is unique or not. For that we have the existence criterion and the uniqueness criterion. So let us at first go for the existence criterion. The solution of the differential equation, this is the differential equation, dy by dx is equals to f of xy. This f of xy, if it is bounded, continuous and single valued function over a given domain D, then we can say the solution for this differential equation exists. So actually what we have done, from the given differential equation, if we write dy is equals to this function into dx, and after that if we integrate this entire thing, then definitely this is the integrating constant will be incorporated. Then after this integration, if this fxy is integrable on the given domain D, then the solution of the differential equation exists. We know the another form also for the differential equation, which is this one. So from here also if we integrate entirely, then we shall find out this one, from where if we can say that m and n both are integrable, then we say that the solution of this differential equation exists. So this is the existence for the differential equation. Now the uniqueness criterion for, so the uniqueness criteria for, we can say that the solution of the differential equation dy dx is equals to f of xy is a unique integral curve through every point xy in the interior of a closed rectangular domain D in the xy plane if the function fxy and its partial derivative with respect to y, that is del f by del y, both are continuous function in the domain D. That is basically the Picard's theorem. So what Picard's theorem actually says? For the initial value problem, dy by dx is equals to fxy, where the initial condition is yx0 is equals to y0 within the rectangular domain with width and length a and b, if f of xy is continuous in R, mod of f of xy is less equals to m, for all xy belongs to R and f of xy satisfy Lipschitz condition in R, then there exists a unique solution in the interval x minus x0 mod of x minus x0 less equals to h, where h is equals to minimum of a comma b by m. This m is this one. So this one is our Picard's theorem. Here I say in the third condition that it should satisfy Lipschitz condition. So at first we should come to know what is Lipschitz condition. So Lipschitz condition says that a function fxy defined in a domain D is said to be satisfy Lipschitz condition with respect to y in domain D if there exists a constant k such that f of x comma y1 minus f of x comma y2 less equals to k into mod of y minus y1 minus y2. And here this k is called the Lipschitz constant. This k is the Lipschitz constant. So that this expression we can rewrite in this format mod of f x comma y1 minus f of x comma y2 divided by mod of y1 minus y2 less equals to k. This is nothing but the partial derivative of f with respect to y. So that we can write del f by del y is less than equals to k. So this is our Lipschitz condition. Till that we come to know about the uniqueness and the existence criterion of the differential equation. It is very simple, just precisely we can say if the function fxy is continuous and integrable, then the existence criterion will satisfy. That means solution exists. And if the derivative of fxy with respect to y, that derivative value exists and it is continuous, then we say the solution is unique. So all those things with some example when we explain, then we can understand that if a differential equation is given, then how to find out that its solution exists or not and it is unique or not. The criterion, the theorems, all is known to us now, and with some example we going to understand the topic quite better. So the first example is dy dx is equals to x plus y square, and the domain is given 0 less equals to x less equals to 1, 0 less equals to y less equals to 2. Here fxy is equals to x plus y square, this we should denote by equation number 1. Now if we take the partial derivative of this function with respect to y, then we shall find out del f by del y is equals to 2y. Now very obvious that this function is continuous, and this function for if we take the mod value, that means the derivative, partial derivative of f with respect to y, we get 2y. If we take the mod value of this one, then we shall find out this one is equals to 2 into mod y, which definitely less than equals to 2 into 2 minus 0, because the initial condition here it is a given that y should lies in between 0 to 2. So y0, y1 we can say 0 and y2 we can say 2. So that if we substitute, we shall find out 2 into 2 minus 0, which is less equals to 4. So it is a bounded condition. Therefore, it is the Lipschitz condition also. Therefore, fxy is continuous. It is very obvious because it is the polynomial function. It is continuous in the given domain. Hence, the solution of the differential equation exists, and from the second criterion, which is the Lipschitz condition, from there we can say the solution is unique for this given differential equation. It is so very simple. Similarly, if we go for the second example, then if it is given x dy dx is equals to 1 and the initial condition is given y0 is equals to 0. Here dy dx is equals to f of xy is equals to 1 by x we can write. So f of xy is equals to 1 by x, which is not exist at the point x is equals to 0. Therefore, we can say fxy not continuous at the point x is equals to 0. Therefore, at y0 is equals to 0, no solution exists for the given differential equation. So, one more example for you, that is root over of dy by dx is equals to cube root of y, where x lies in between minus 1 to 1 and y is equals to 0. For this solution, given dy dx is equals to y to the power 2/3, because if we just simplify, we shall find out in this way. Here f of xy is equals to y to the power 2/3 we can say. If we take its partial derivative with respect to y, then we shall find out 2/3 into 1 upon y to the power 1/3. Therefore, if xy is continuous, because this function is continuous for all y values, hence the solution exists. Again, this function does not exist at y is equals to 0, because at y is equals to 0 this is undefined, hence the solution is not unique. So for this given equation, solution exists but it is not unique. One more example let us do. So the example is given dy dx is equals to mod x. Therefore, f of xy is equals to mod x, which we can write as x if x greater than 0 and minus x if x less than 0. If we take the derivative of this one, then definitely it is 0. Therefore, fxy is continuous and hence the solution exists. And del f del y also satisfies the Lipschitz condition. Here, if we take the mod value, then it is less than equals to 0 always. So, it satisfies Lipschitz condition and the solution is unique also. So, the solution for this differential equation exists as well as it is unique. Let us do one more example. It is dy by dx is equals to x into mod y. Here we should prove that del f del y does not exist if x not equals to 0. So for the solution, given fxy is equals to xy when y is greater equals to 0 and is equals to minus of xy when y less than 0. Just look at the question. Accordingly, we can write this one. Therefore, its partial derivative if we take with respect to y, then it will gives us x when y greater equals to 0 and it is minus x when y less than 0. Therefore, if x not equals to 0, then del f del y does not exist. Is it now? So, this one is the solution for the given differential equation. Now, one question I am giving you for your reference. This is the do by yourself question. So, the question is dy by dx is equals to 2 root y, where y0 is equals to a. Now, among these 4 conditions, which one is true that you are supposed to give me the answer? So, the first condition is unique solution if a less than 0, no solution if a greater than 0, infinitely many solution if a is equals to 0, and again unique solution if a greater equals to 0. So, I hope you can understand what is the uniqueness and the existence criterion of the solution of a differential equation, and you should solve this equation, this do by yourself equation, and write its answer in the comment box. This is the video where we come to know the simple methods to solve the first order differential equations. So, how many different methods are there to solve this first order differential equation, that at first we should come to know in this video. But before that, the general form of a first order differential equation is dy by dx is equals to f of xy. This equation also can be written as m dx plus n dy is equals to 0. We can just simply dy keep in one side and dx if we multiply this side, and if we keep everything in the left hand side, then we shall find out this type of format. So from here only we can derive this format also. So these are the any two format in which you may find out your first order differential equation, where this m and n are either the function of x and y or a constant. So this is the formation of that. This is the formation of the differential equation and how to solve this differential equation and what are those methods that we should come to know now. So the first method to solve is equation solvable by separation of variable. Equation solved by separation of variable. Second one is homogeneous equation. Second way to solve a differential equation is homogeneous equation. Of course, your equation should be in this format, then only we can solve by this. Third one is any equation if not given in the homogeneous equation, then we may reduce the equation in the homogeneous equation and after that we can solve. So this is the third option, that is the equations reducible to the homogeneous form, and after that we should solve it. Third one is the exact differential equation, and the fourth way to solve is equation reducible to the differential equation, equations reducible to the exact differential equation. The sixth method is the linear differential equation, and the last one is equations reducible to the linear differential equation, equation reducible to the linear differential equation. So what are those 7 kind? Equations solvable by separation of variable, homogeneous equations, then equations reducible to homogeneous equation, exact differential equation, equations reducible to exact differential equation, then linear differential equation, and finally equations reducible to the linear differential equation. As in our last video, we come to know that differential equation, in fact first order differential equation, we can solve by various methods. Among those methods, the first one is the separation of variable method, and using this separation of variable method we are now going to solve the differential equation. So the first of all, the differential equation is of the form dy by dx is equals to f of xy. This one we can put into the form f1x dx plus f2y dy is equals to 0 if it is possible to solve this differential equation by the method of separation of variable, where this f1x and f2y, these are the two functions. f1x is the entirely a function of x and f2y is entirely the function of y. So if we can separate the given differential equation in this format, then by direct integration we can find out the solution of this differential equation. So if this is the form, we just take the integration on both sides. So by integrating simply we can find out the primitive which is of the x, y and c. C is the integrating constant, and this one is the general solution. So how to find out this one and what actually the solution looks like, we just explore that by using some examples. So the first example is given here, x by y into dy dx is equals to y minus 1 divided by x minus 1. So just look, this is dy by dx is equals to, if we write this y by x here, this entire form here, y by x into y minus 1 divided by x minus 1. So this one is nothing but our f of x comma y. So if we can rewrite this given equation in this format, that is dy, then here y we just let it be, and this y minus 1 we write here, and this x terms all we write here. Then just look, we just simplify the given equation in the form of, here it is f of y, this is entirely the function of y, and dy is equals to f of x into of dx. So in this format, when we can able to reduce a equation, then just by take the direct integration on both sides to get the desired general solution. Here we just simplify this one a bit. We just write 1 divided by y into y minus 1 in this format, 1 by y minus 1 minus of y 1 by y, just to ensure that our integration becomes easier. And exactly similar way we can just write in terms of x also, as both the terms are almost same. So now we take the integration on both sides. So the first integration value is log of y minus 1, then minus of log y is equals to, here its integration value is log of x minus 1 minus of log of x is equals to, and plus the log c, that is the integrating constant that we have to introduce after each and every integration when it is the indefinite integral. Now while we simplify, then we get x into y minus 1 divided by y into x minus 1 is equals to c. So which is the required general solution? Here is one more example, that is dy by dx is equals to e to the power x plus y then plus of x into e to the power y. So this one at first we just simplify, or we just rewrite this given equation in the form of x to the e to the power x into e to the power y. That one easily we can write in this format, then plus of x into e to the power y. Now e to the power y we should take common from here to get this one e to the power x plus x into e to the power y. Now just look, this one is the entire function of x and this is the entire function of y. Now if we separate them x and y variable, then we will find out e to the power minus y dy is equals to e to the power x plus x into dx. So this one is the separation of variable form. Now just simply we take the integration on both sides to get the desired solution. So if we integrate this one, then its integration is minus of e to the power of minus y is equals to, here e to the power x after integration remains e to the power x plus x for its integration is x square by 2 and plus c, which is the integrating constant. Hence, if we simplify, then we shall find out e to the power minus y plus e to the power x plus of x square by 2 is equals to minus c, which we may replace by d, another variable, and this one is our desired general solution of the given differential equation. So it is so very simple. Let us do one more example to establish our method. So now the third example, here it is given dy dx is equals to y tan x. So that one we simplify as tan x as sin x by cos x, and after that we just separate the variables so that we will find out dy by y is equals to sin x by cos x into dx. Now as usual we take the integration on both sides, and after integration we can write it is the log of y. We should write within the mod because always we take the positive value. Then minus of log, here it is cos x, just its integration is log of cos x, and minus sign as the cos x if we consider as z, then its derivative is minus of sin x is equals to dz. Anyways, so plus of log c, which is the integrating constant, and after simplification we shall find out, here it is y cos x is equals to c. So which is the general solution. So I hope you can understand the method very easily, and yes, it is a very simple method to solve. Now just let me check how much you understand better. So that here few questions for you. These are your do by yourself question. So you should do these questions by yourself, and for simplicity I am providing the answer of each equation. So you should solve this equation by yourself and verify your answer from here. So the first equation is dy dx is equals to xy minus x minus y plus of 1, and this one its solution, general solution. So you should solve and verify that you are right or wrong. Here is the second question. So the second question for the question is x dy dx minus y whole into x is equals to y, and here it is its solution. Now the third question is here for you. So the third question is sec square x tan y dx plus sec square y tan x dy is equals to 0, and this one is your answer. And one more question, this one is log of dy dx is equals to alpha x plus beta y, and its answer I am not going to give you. You should solve this fourth question also, and whatever the solution you find out, you should type your answer in the comment box of this video. In this video, we are going to know about the second method of first order differential equation solution. In the first method, we come to know it is the separation of variable, and the second one is nothing but the continuation of this first one. In the first method, the separation of variable, there are differential equations which we can separate into two variables very identically. But there are few equations given which can be solved by the separation of variable method, but after some transformation. For that transformation, for the variables, we substitute some another variable and we reduce the given differential equation in the form of separation of variable method. So now at first suppose the given equation is in the form dy by dx is equals to f of ax plus by plus c. So if this type of formats are given for the differential equation, then these equations can be reduced to a simpler form where the separation of variable method can be substituted. So now for this equation, if we want to solve, we should put this entire ax plus by plus c is equals to z, some another variable. After that we take the derivative with respect to x for this one, so that we will find out here dz by dx is equals to a plus b into dy by dx plus 0. C is a constant, that's why its derivative is 0. So that by differentiation we shall find out this one, and from here we will find out dy by dx is equals to 1 by b dz by dx minus of a. Now these two values, z value and this dy dx value, we should substitute in the given equation. So if we substitute, then we shall find out the given equation as 1 upon dz by dx minus a instead of dy dx is equals to f of z instead of that entire function, as we assume this entire variables are z, that's why we should substitute z. So now after getting this one, if we simplify, then we shall find out it is in the form of dz by dx is equals to b fz plus a. So we can separate the variable z and x here, so that after separation we can write dz divided by b into fz plus a is equals to dx. Now it is a very simple thing. As previous one, we can solve this one just by integrating both sides. Both sides we should integrate, and after integrating we shall find out the solution, that is the general solution in terms of z and x. And we know what is the z value is. So after complete solution, we should substitute the z value in this general solution to get the general solution for the given differential equation. So that is the method, but this is the first way, because there are another type of form also for the differential equations we might have. Anyways, we should discuss later on. At first, this type of differential equation, if we shall find out, then how to solve with an example, we are going to solve it out. So here is the first example. Suppose your equation is given dy by dx is equals to x plus y its whole square. Just look, here it is not possible to separate x and y completely. That's why we should substitute x plus y is equals to z. If we take the derivative on both sides with respect to x, then we shall find out dz by dx is equals to 1 plus dy by dx. Now from here we find out dy by dx is equals to dz by dx minus 1. Now this value we should substitute here, and z x plus y for we should substitute z here. So after this substitution, the equation becomes this one. So after substituting all those in the equation and simplifying, we shall find out dz by 1 plus z square is equals to dx, which is in the form of separation of variable. So now if we integrate on both sides, then we shall find out its integration is tan inverse z is equals to x plus c. Now as I told you that z for we should substitute the value of z is equals to x plus y as for our assumption. That's why if we substitute this value of z, then we shall find out tan inverse x plus y is equals to x plus c, which is the general solution for the given differential equation. So I think it is very easy. Yes. So now one more equation I am giving you, but not going to solve for you, because this is your do by yourself question. So the question is very similar to the previous one. So it is x plus y its whole square dy by dx is equals to a square, and its solution I am not going to provide you, because I am expecting this answer from you, and you should write down this answer in the comment box of this video lecture. Now one more question for you, and the question is cos of x plus y dy by dx is equals to 1, and here is its solution. So that one you should verify by yourself, but the second question you should solve, and its answer you should write in the comment box. Now one more method, in fact one more format we shall find out for the differential equation, which we can solve by separation of variable method by some other substitution. So let us check. So, if you find out the differential equation is of the form dy by dx is equals to f of y by x. All the variables are in the form of y by x. If you shall find out this type of equations, then also we can reduce this differential equation in the separation of variable form by some other substitution. In fact, this format is the homogeneous form, and what is homogeneous form in details we shall discuss in our upcoming video. Anyways, just forget everything. Now you just remember, if the equation in this format, then what to do. Here, if you shall find out this type of equation, then you should substitute y is equals to vx. Actually, y by x is equals to v, some another variable we just simply substitute, and after that we take the derivative of this one, so that if we take the derivative of this one, then we shall find out dy by dx is equals to, here it is the v by x, v into x, that means it is the uv format and the first function derivative of second plus second function derivative of first. So, accordingly we shall find out this one, and this dy dx and the value for y by x is equals to v, we should substitute in this given equation. So, after substitution we shall find out the equation in this format, and after simplification and separation of variable we shall find out dv divided by fv minus v is equals to dx by x. So, yes, it is in the separation of variable form entirely. Now, very simple, we should take the integration on both sides. After getting the value of integration, we will, whatever the primitives we shall find out, that is the solution, general solution, and on that general solution, wherever you shall find out v, instead of that you should replace it by y by x to get the general solution for the given differential equation. So, let us do with an example again. So, the first example here, it is given that dy by dx is equals to y by x plus sine of y by x. Just observe, the variables are in the form of y by x. So, we should put y is equals to vx, and its derivative we know, dy by dx is equals to v plus x into dv dx. So, substituting all those values in the given equation, we shall find out here, instead of dy by dx, we should substitute v plus x dv dx plus dy dx for v, and sine y by x is equals to sine v. So, that after this substitution and simplification, we shall find out from here, it is dv by sine v is equals to dx by x. Sine v we can write as cosec v. So, now if we take the integration on both sides, then we shall find out that cosec v, its integration is minus of log of cosec v plus cot v, and the integration for this one is log x, then minus of log c, which is the integrating constant. Just for simplicity or just for the adjustment, we put here minus sign, otherwise you can put plus sign also, it does not affect your solution. So, after simplification we shall find out the solution as x cosec v plus cot v is equals to c. So, substituting the value of v, we get the desired solution as x cosec y by x plus cot y by x is equals to c. You may more simplify this one by converting cosec x into sin x and cos x as cos x by sin x, and after that by simplifying you may get the answer in terms of sin and cos also. So, anyways, two questions again here for you for your own solution. So, you should try these two equations to solve, and if you are able to do both the question, then you may sure that you understand the separation of variable method completely. So, the first question is dy by dx is equals to y by x plus y square by x square. Its solution is x is equals to c into e to the power minus of x by y. You should try by yourself. And the second one is dy by dx is equals to minus of y into x plus y divided by x square, and its solution is also given. You should verify and keep trying. This method is about the homogeneous differential equation. If your differential equation is in the form of homogeneous equation, then how to solve that we are going to learn here. But before starting the homogeneous differential equation, its solution, we should come to know what is homogeneous function. Hope all of you find out or all of you know what is a homogeneous function, but still in this video itself I am just giving you a brief introduction that what is homogeneous function. So a function f of xy is said to be homogeneous function of degree n if we substitute instead of x lambda x and instead of y lambda y, and after this substitution and simplification, if we shall find out the result as lambda to the power n f of x comma y, then we say the given function is homogeneous and it is of homogeneity n. Okay, so this one n can be definitely a integer or any real number. So let us do that one with some examples so that we can understand better. So the first example is, suppose fxy is given x square plus y square, and the question is it a homogeneous function? If yes, then what is its degree? So what we will do? Instead of x, we substitute lambda x, and instead of y, we substitute lambda y. So after this substitution and simplification, we shall find out lambda square f of xy, because this one x square plus y square we shall find out, which is nothing but our given f of xy. So if we can find out any such substitution for this expression, then we can say the given function is homogeneous, and the power of this lambda will specify the homogeneity of the given function. So the degree of this function is 2. One more example is here. If your function is f of xy is equals to x square plus y square minus xy by x plus y. So is it homogeneous or not? So for that, again we just substitute x for lambda x and y for lambda y. After simplification, we shall find out lambda f of xy. So yes, the given function is homogeneous and its degree is, yes, it is 1. So one last example for homogeneity test. So fx is equals to fxy is equals to x square sine x by y plus xy. Again we substitute x for lambda x and y for lambda y and simplify. We find out here lambda square f of xy. So definitely this one is a homogeneous function of degree 2. So in this way we can verify the given function is homogeneous or not, and if it is homogeneous, then what is its degree. So at first, whatever be the differential equation given, it is homogeneous or not, we should verify. In fact, homogeneous function for, we know the differential equation in the form of dy by dx is equals to f of xy. If we can express this differential equation in this format, f1xy dx plus f2xy dy. So we should verify that this f1x y and f2xy both are the given two functions, and these two functions are homogeneous or not. And if f1 and f2 both are homogeneous, then they have the same degree or not. If f1 and f2 both are homogeneous with the same degree, then only we can say the given differential equation is in the form of homogeneous equation, and we can able to solve by this method. I hope you understand. At first, dy dx is equals to f of xy. This one is a differential equation given to you. We should express this one in this format, that means dx with some function and dy with some function, and these two functions are homogeneous or not, and if they are homogeneous, then they are with the same homogeneity or not, we should verify. After that verification, we shall come to the conclusion that yes, the given function is in the form of homogeneous equation. Now we can able to solve. So how to solve? For that, I am just at first giving you a bit theoretical expressions. After that, I am coming to the example. So here this expression for, we can able to write this one as dy by dx is equals to minus of f1xy divided by f2xy. So this entirely we can replace by another function phi of xy. So if f1 and f2 both are homogeneous and of same homogeneity, then definitely this one phi function is definitely a homogeneous function with degree 0. It is understood. So after writing dy by dx is equals to phi of xy, as the function is homogeneous, we definitely can write dy by dx is equals to phi, or this is psi of y by x. This is the form of homogeneous function. If you can remember, then just in the previous video of this one, we just solve such type of equations by reducing separable of variable method, if you can remember. And if not, you just check the previous video of the equation reducible to the separation of variable form, where you shall find out this one. So anyways, I am solving few questions from here also, but before that just let me tell you this one. For if we put y is equals to vx and dy dx is equals to this one, then after substitution of these two, the equation becomes this way. So here the separation of variable we should imply, and if we just integrate, then we shall find out the primitive in terms of b. There b should be replaced by y by x to get the desired solution for the differential equation. So let us solve this one by one example. So the example is given as x dy dx minus of y is equals to root over of x square minus y square. So at first we should write dy by dx is equals to y plus root over of x square minus y square by x. Just take this y here and divide the entire equation by x to get this one. So from there we can write it is y by x plus root over of 1 minus x square by y square. And this is nothing but in the form of f of y by x. So it is a homogeneous function. Now we should substitute y is equals to vx and simplify. Just we know the process of simplification exactly in the similar way. We should solve it. We just substitute the value of y by x and dy by dx in terms of v and x, and after simplification we find out here dv divided by root over of 1 minus v square divided by dx by x. So now integrating on both sides, we get sin inverse v is equals to log x plus c, where c is the arbitrary constant, and if we substitute v for y by x, then we shall find out the general solution as sin inverse y by x is equals to log x plus c. So I hope you understand the method. Now here few questions for you, for your reference, solve by yourself and just ensure that you understand the method quite well. So the first question for you is x cos y by x into dy by dx is equals to y cos y by x minus of x. Here is its solution. One more question for you is x dy dx is equals to y plus x e to the power y by x. Solve this one and here is the solution for you. And one more and the last question for you, it is the x tan y by x minus y sec square y by x into dx plus xx square y by x dy is equals to 0, and here is its solution. If you have any kind of problem to solve those equations, then you should write me in the comment box. And last video we come to know about the homogeneous differential equation. In this video we are going to learn about differential equations which are not homogeneous but can be reducible to the homogeneous form. So such type of equations are given as dy by dx is equals to ax plus by plus c divided by lx plus my plus n. If the differential equation in this format, then this one is definitely not a homogeneous differential equation, but we can reduce the differential equation into the homogeneous form, and after that we can solve it out. So how to reduce that we are going to learn now. There are basically two cases we can find out. If the equation in this format, then their coefficients, the coefficients of x and y, x coefficient is a by l and y coefficient b by m we can write. So if this coefficient values are equal and not equal, there are such two cases we may find out. If this a by l not equals to b by m, then we can find out that we can just substitute x is equals to x dash plus h and y is equals to y dash plus k, where h and k are suitable constants to be determined later on. Now what to do with this substitution? At first we take the derivative on these both so that we can find out dx is equals to dx dash because h is a constant and dy is equals to dy dash because k is a constant. Now substituting this x value, y value, dx and dy in this given equation, we shall find out here dy dash by dx dash is equals to ax dash plus h plus by dash plus k plus c divided by l x dash plus h plus m y dash plus k plus n. Now if we simplify, then we shall find out from here this one, and this constant terms AH plus BK plus C and LH plus MK plus N, these are the two equations we should find out here in terms of H and K. Now we choose this H and K in such a manner so that these two becomes 0. So how we will do that? Just make this one and this one equals to 0 and solve for H and K. After the solution, we can find out the H value and K value. For those two values of H and K, we shall find out these two terms are 0. So when for the particular H and K value these two are 0, then our equation reduces to dy dash by dx dash is equals to ax dash plus by dash divided by lx dash plus my dash. Now this one is the homogeneous in terms of x dash and y dash. So this above differential equation now can be solved by just simple substitution of y dash is equals to vx dash that we know from our previous video. So let us do one example corresponding to that so that we can understand better. So the given question is, suppose it is dy by dx is equals to 2x plus 2y plus 1 divided by 3x plus y minus 2. Now if we just at first verify the coefficients of x and y, then we shall find out here a is 2, b is 2, l is 3 and m is 1. So if we shall write down it 3 by 2, then that one, and here it is 2 by 1. So definitely 2 by 3 is not equals to 2 by 1. So that our equation in this format a by l not equals to b by m. So if in this format equation is, then definitely we should substitute x is equals to x dash plus h and y is equals to y dash plus k. So that take the derivative, and in the above equation if we substitute the value of x, y and dx and dy, then we get this one. So just look, have a look, dy dash by dx dash is equals to 2x dash plus h plus 2y dash plus k plus 1 divided by 3x dash plus h plus y dash plus k minus 2. Now by simplifying we get this one, and here these are the constant terms. So if we take 2h plus 2k plus 1 is equals to 0 and 3h plus k minus 2 is equals to 0. 0 means we should find out from these two equations the h and k value in such a manner so that these two terms are 0. So if we will do so, and just let us solve this one. So we solve it by the cross multiplication method. So h we should take it here, and this cross multiplication for we shall get this value. I hope you know this method, but still I have just solved it out for you. So accordingly we find out h value is equals to 5 by 4 and k value is equals to minus of 7 by 4. So that the differential equation becomes now dy dash by dx dash is equals to 2x dash plus 2y dash divided by 3x dash plus y dash. So which is a homogeneous equation in x dash and y dash? So now definitely we should substitute y dash is equals to vx dash and take the derivative of this one to get dy dash by dx dash, which is v plus x dash into v dv by dx. So now if we substitute all these values in the given this differential equation, then we shall find out here instead of dy dash by dx dash we should substitute this one, so that we get v plus x dash dv by dx dash is equals to 2 plus 2v divided by 3 plus v, because here the y is equals to vx dash. If we substitute and take x dash common, then x dash cancel from denominator and numerator, and at the end we shall find out this one. So hence if we now simplify, then we will find out here x dash dv by dx dash is equals to 2 minus v square divided by 3 plus v. So we can separate the variables now. So by this separation of variable we find out this one. Now look, this one directly we can't integrate, that's why we should break into the fractional form. So we know how to break this one, but still I do for you. So this one we can write in the form of a plus 2 by v plus b by 1 minus v. So that we take just simply the LCM of this one, and by comparing we find out 3 plus v is equals to a into 1 minus v plus b into 2 plus v. So if we solve for v is equals to 1, we find out the b value is 4 by 3, and if we solve for v is equals to minus 2, we get the value a is equals to 1 by 3. So if we substitute this b and a value here, then that one we can express in the form of this one. Just look, 1 by 3 dv by 2 plus v plus 4 by 3 into dv divided by 1 minus v is equals to dx dash by x dash. Now we should take the integration on both sides and get 1 by 3 log of 2 plus v minus of 4 by 3 log of 1 minus v is equals to log x dash plus log c, which is the integrating constant, and after simplification we shall find out this one in terms of v and x dash. So v means we know it is y dash by x dash, so that we should substitute the v for y dash by x dash. After this substitution we shall find out this one, and here our equation in terms of x and y, and we know x is equals to x dash plus h that we have substituted, and y is equals to y dash plus k, so that we should resubstitute here. So x dash is equals to x minus h and y dash is equals to y minus k, and we know what is the value of h and k, that we should substitute here, and after getting this value of x dash and y dash we should substitute that one in this derived equation, and after substituting and simplifying we shall find out 2x plus y minus of 3y is equals to c cube. This is the integrating constant, then x minus y minus 3 whole to the power of 4, which is our general solution. So in this way we can solve it out. Now the second method, in fact in this case 2, when a by L is equals to L by M, that time we can take this one, this ratio is equals to 1 by R. So that we can say L is equals to AR and M is equals to BR. Now if we substitute this L and M in terms of A and B in the given differential equation, this one, then we shall find out here that AX plus BY plus C divided by R we can take common from this first two terms, so that we get AX plus BY same as the above one plus of N. Now here we should substitute Z is equals to AX plus BY and take the derivative, and these two values we should substitute in this given equation to get the differential equation in this format. So after substituting and simplification we can now separate the variables very easily, and after separating the variable we shall find out this one. So now which can be easily integrated, and hence we obtained the solution. So how to find out the solution? With an example let us do it. So here it is the given differential equation, dy by dx is equals to 4x minus 2y minus 5 divided by 2x minus y. So at first we should compare the coefficient. So it is 4 by 2 and it is 2 by 1. So definitely both are same. So it is 4 by 2 is equals to, we can write 2 by 1. So just look, these are the equal because we can cancel it out. So accordingly we just simplify and take z is equals to 2x minus y. After that if we take the derivative of this one, then we find out dz by dx is equals to 2 minus dy by dx. Now substituting these values of dy dx and z in this equation, we find out the equation as this one, and after simplification we shall find out the equation in the form of this one. So from here we can easily separate the variable, and after separation of variable we find out z dz is equals to 5 of dx, and now integrating we find out z square by 2 is equals to 5x plus c. Now in this one we can substitute the value of z because we know z is equals to 2x minus y. So after that substitution we get this one. So it is 2x minus y square minus of 10x is equals to 2c, and by simplifying we get this one as the general solution. So it is so very simple. Now there are two questions for you. These are the do by yourself questions, and for your reference I am also giving you the answers so that you can verify by yourself. So the first question for you is x minus y dy is equals to x plus y plus 1 dx. Its answer is this one. And one more question for you, it is x plus y dx minus dy is equals to dx plus dy. Solve these two differential equations by yourself and verify your answer which are given here. If any problem you will face, then you should write in the comment box and definitely I give you the answer. Until then, have a nice day and thank you all.